Okay, so in today's lesson, we are going to be looking at velocity and acceleration in simple harmonic motion. That is the proof, how to obtain the formula for the velocity and acceleration in simple harmonic motion. And we'll be looking at simple harmonic motion from circular motion. So in this diagram, you will notice that the object is moving around, and at a particular time, the object is here. And of course, its reflection will be on this horizontal axis here. And the distance of this point from the central point will be our x. So we are going to bring out this right angle triangle, and of course from here to here is our amplitude. So we are going to, and the amplitude is representing the radius of this whole circle. So we are going to bring out this right angle triangle, and then we are going to see how we can obtain our velocity and acceleration. So bringing out the right angle triangle, I have it this way, and of course I have my theta, and I have my amplitude, and I have my x. The x is my displacement from the center, from the central position. So using SOHCAHTOA, I know I have my adjacent and I have my hypotenuse, and from SOHCAHTOA, adjacent hypotenuse leads me to use cos. So I'm going to say cos this angle must be equal to the adjacent, which is x, over the hypotenuse, which is my amplitude a. And then I want to make my x the subject of this formula. Now I'll cross multiply. So x times 1 gives me x. Then a times cos theta gives me a cos theta. So this is my first equation here, equation 1. But notice that theta here, I can replace theta because I know that my angular velocity equals, I know the angular velocity, which is my omega, is equal to angular distance over time, since our angle is going to be in radians. So if I cross multiply, my angular distance equals to omega times time, so omega t. So I'm replacing this theta here with omega t. So I'm rewriting this as x equals to a cos then omega t, and then I have this as my equation 2, and then I'm going to differentiate with respect to t, differentiate x with respect to t. So I'm having the x, the t, so the x, the t will now be equal to, if I'm differentiating this one, don't forget, I'll since my a is standing in as the coefficient of the whole cos omega t, and I'm differentiating with respect to t, the coefficient of t itself in this this whole value is my w, my omega. So I'll multiply this by a to give me aw, and then times, I'll now differentiate this one with respect to t, and if I'm differentiating cos omega t, gives me minus sine omega t, and then I'll multiply through, and my dx dt now gives me, this times this, of course I now have minus wa sine omega t if I multiply through. And don't forget that my dx dt is also equal to my v. Don't forget that my v is also equal to dx dt. That's change in distance over change in time, or displacement over time. So I'll replace my dx dt with v now, and I have v equals minus omega a sine wt. And then, of course, dx dt is now my v. I can call this one equation 3. And I can decide to square both sides. So I now have v squared equals to minus omega a sine wt, everything raised to power 2. And of course, if you have everything raised to power 2, you can now have it as, let's say, v squared is now equal to minus 1 squared. Of course, you know you have minus 1 here, this manner, then w squared, that's times w squared, then times a squared then times sine squared omega t, and of course minus 1 squared is still 1, so I just have only v squared equals to omega squared times a squared times sine squared omega t. Then following trig identity, I can replace this sine square omega t with 1 minus cos squared omega t. So sine squared omega t is also equal to 1 minus cos squared omega t. So now I can rewrite this as v squared equals to omega squared times a squared times, all in brackets, 1 minus cos squared omega t. Is omega t, cos squared omega t. Then I will just use only my amplitude a squared to multiply through the bracket, so the bracket still remains there since my omega squared is still here, and I have it this way: v squared equals omega squared bracket a squared times 1 is still my a squared, plus times minus minus a squared times cos squared omega t gives me a squared cos squared omega t. And of course a squared cos squared omega t can be written as, if I continue from here, can be written as, let me write everything in full, v squared equals to omega squared bracket a squared minus everything a cos omega t all squared, then the overall bracket. And notice that a cos omega t is equal to a cos omega t equals x, so I'm replacing this with x. So I now have v squared equals omega squared open bracket a squared minus x squared, since there's a squared there already. Then I now have v squared equals w squared open bracket a squared minus x squared, then close bracket. Then I can now find the square root of both sides. So I now have, and the square root will cancel this square here, and I have v being alone equals the square root of w squared and also the square root of every value here, which is a squared minus x squared. And w squared, was the square root, is just w, so I now have v equals w into a squared minus x squared. So this is formula for finding the velocity in simple harmonic motion. This is equation 4. Now for acceleration, we know acceleration is also equal to the v dt. So our v is here already. We already have our v as, so the v is equal to minus w a sine omega t. So we are going to do the v dt according to what I have here to get my acceleration, and that's with respect to t. So the v dt will now be equal to, of course, how did we differentiate before? We are multiplying, since we are it's going to be with respect to t, I'm multiplying this w with the overall coefficient of the sine omega t, which is minus omega a. So w times everything here gives me minus w squared a, then times, if I differentiate this, I get cos omega t. So I now have the v dt will now be equal to minus w squared a cos omega t. But this a cos omega t is already equal to x here. So x equals a cos omega, so I'm replacing it back with the x. So my dv dt, which is my acceleration, is now equal to minus w squared x. So that is it. This is how you prove, you give a breakdown on how to get the formula for finding the velocity and acceleration in simple harmonic motion. Very simple. You can place down your comments or your suggestions in the comment section. God bless you.